So welcome to yet another OpenChain webinar. This time we're delving into a topic that has come up again and again and again over the years, container compliance. People do find containers incredibly useful, and they are. It's remarkable what we can do deploying in containers, but it's also remarkable how little insight we tend to have in what is in our containers. And naturally, that's important from a compliance perspective. Now, we're very lucky to have Karen from OSADL here today to talk about compliant containers and OSADL's base image approach. For those who don't know that OSADL is an organization in Germany that has been at the forefront of progressive matters around compliance, management, and all in all, good governance for open source for many, many, many years. So this is yet another initiative from our good friends over there. Before we get started, I'm just showing the antitrust policy notice. Full antitrust policy can be found on the Linux Foundation website. And if you're from a member company, you can ask any questions of our council, Andy Updegrove. But long story short, this is a way for us to talk comfortably and openly together, and it's shown at the beginning of every meeting. Well, without further ado, I think I should hand over to Karen and let her do her presentation and explain all the wonderful things OSADL is doing.
All right, thank you, Shane. Give me a moment to share my screen.
While Karen is sharing, I'll just make a note that I'll keep an eye on the chat as we go. So if you have questions, feel free to raise them there. But you can also interject in the conversation. Just imagine we're in a room chatting.
There you go. Can you see the screen?
It's perfect.
Perfect. Thank you. Yes, like Shane said, please interrupt at any time. Just speak up. I'll also try to keep an eye on the chat. So if you'd rather type something than speak up, then I'll try to catch that as well. Anyway, so as Shane has said before, this topic of compliance with containers has come up many, many times. And for us, the journey actually began in 2020. So about 5 years ago, with a white paper that Armin Hemel wrote on the topic. And we did a webinar on that topic back then. I'm kind of exploring what the issues or what's special about containers when we're talking about compliance. And I'll start in the very beginning here with this. So I'll jump over the basics fairly quickly because I think everyone who's here is familiar with the basic setup of containers. Just to mention a bit of wording, I'm going to say container all the time. Most of the time I talk about container images. So not the running container, but the collection of software that I have on my disk, basically in the form of a container image. Sometimes I might talk about a running container, so the running instant, which is created from that image. We'll also talk about container files. And of course, there is the container engine that manages all of this. And usually it becomes clear kind of from the context what is meant when saying container. Well, you know why containers are popular. So I don't think I'll need to repeat that. It just makes distribution, it makes deploying software really easy because everything is, as it says, contained in this blob. Now it becomes a bit more interesting. How is a container image actually made up? And we know this. We have stacked layers that contain different components, functionalities, maybe customization. This might look like this. So I usually have some kind of base layer in my container that contains typical system requirements like a C library, a package manager, a shell, networking functionality, and so on. I have some kind of customized application on top, maybe some libraries that this application needs as well. And maybe I customize this particular application a bit more in another layer. Of course, this can go on further and further, so you can add additional layers to your container to customize it as far as you would like. Now, why is this relevant? Let's look at what these layers might contain. So some kind of files, some kind of programs. We'll have some of these files in a base layer. In the second layer, we might add additional files. And in the third layer, we might even remove files or modify files that were added in lower layers. And now this is kind of the makeup of a container image. And if I start a container, so in a container instance from this image, then the running container looks something like that. So the runtime view is only the result of all of these layers. But all components, even the components that were deleted from lower layers, are still contained in the image. And if components were modified, then the unmodified component is also still contained in this image, but it is not visible from the running container. And what are all these letters that are in this container? Well, most of the time, well, it says here most containers include FOSS. In truth, all containers include FOSS, because usually you don't build them entirely up from scratch with proprietary software. And you all know, when copying, distributing FOSS, we need to obey license obligations, including information obligations, so delivering some kind of material, disclosure obligations, delivering source code or offering source code, and if applicable, licensing obligations as well. Well, the issue with containers in this point, so this is normal stuff. We know that this is true for all FOSS. So the specialty about containers is that it's not obvious what software is actually distributed within the container if you look at a running instance, because there might be some software in lower layers down there that is not visible and that you can't see. However, copyright law doesn't care if software is ever used, if it is visible, if it can be modified, if it is running. It doesn't matter for copyright law. As long as you copy and distribute, you have to obtain a license, so you have to fulfill license obligations for all software that is distributed. And the second issue here, and I think that was a discussion that went on the mailing list as well, is that public container repositories often, or we could almost say always, do not provide any compliance information in their containers. However, that doesn't help you if you are the distributor of a container. So you can't say, well, the container repository didn't contain any information, so I can't really do anything about that. If you are the distributor of container software, then you are responsible for license obligations. Now, you might say, well, I don't actually distribute any container software. I don't actually distribute any container images. What I do is that I write a container file that only references public repositories, and I simply distribute this container file. So this container file basically is a script from which a container engine can assemble a container image. It kind of contains download information, and the software that is referenced in this container file is then downloaded at the recipient's point. And now you might ask, okay, so I didn't actually distribute any software, only the container file. Who is now responsible for license compliance of the software that is downloaded per the instructions in this container file? Who is the distributor of this software? And I mean, this is not quite an easy question, but we had a legal opinion. So after this first encounter with container compliance that we had in 2020, we asked Till Jäger to write a legal opinion on container compliance. And what he found there on container files is that it is the person who controls the distribution of software. And there's actually quite a few instances where German and European courts have said something about this topic. There on this slide here, you can see a quote from this legal opinion. And on the last slide, I'll actually give you a link to this legal opinion so that you can read up on that if you're interested in more details. But the point is that the person who actually controls the distribution is the person who is the distributor. And seeing as if you write a container file, you decide which software is downloaded from what repository, and therefore this is the control over the distribution of the software. Well, the result of that is that distributing a container file is equal to distributing software, meaning license obligations have to be fulfilled even when distributing a container file. And we know again the difficulties for that. Repositories don't contain compliance materials. So if I just point at a repository that I know distributes unlicensed open source software, then I become responsible for that. And there is another issue that I think will probably not be an issue in the future anymore because of other regulations that come in with that. But it still is the case that you might point to not a specific given version of software in your container file, but you may point to, for example, the version latest, and then this just points to different software at different times. So if you distribute a container file that gives a software version latest, then you don't even know what software is actually distributed at the time that the recipient of this container file runs this file. So that is, both of those are issues when we're dealing with license compliance. Well, this was the point where we were at in 2020. And we weren't really happy with that. So this is what we presented to our members back then. And it's not a very satisfying situation, as you can imagine. Also, we found that most tooling to analyze containers wasn't super reliable back then. So maybe this has changed by now. So if you have any experience with that, I'm happy to hear about that. But back then, at least, the tooling to analyze container software wasn't very reliable. So what we did, as I mentioned before, is that we said, okay, we're not going to stop here, but we'll ask for, or we'll try to find some solutions for that. And the first step in that was the legal opinion that Till Jäger wrote, thinking mainly about what can we do in this case of distributing container files. Is there maybe a way to say that some bits that are referenced in this container file aren't actually individually distributed software, but can be seen as kind of system requirements. And this is where this idea of a base image came from, because the result of this legal opinion was that if you distribute a container file, and this container file references a base image, and this base image is distributed in a license compliant way, then you can see this as a system requirement and don't need to take care of the license obligations yourself. Well, that is all nice and pretty, but it still won't help as long as there are no license compliant base images available. And so we said, okay, a license compliant base image it's open source in its perfection. So applying the open source principles of shared development of things that are used by everyone in the same way, non-differentiating technologies. And then container-based image is certainly such a non-differentiating technology to apply this principle to the license obligations of container-based images. And that is, of course, something that is made for OSADL. So many of our member companies use containers and use these base images and would like to do so in a compliant way. So we said, okay, we'll provide a license compliant base image. Now, what does this look like? Well, it's a base image. It's basically equivalent to the base images provided by the distributions, by Debian, by Ubuntu, by Alpine. So it has the minimal essential GNU tools like a shell, a C library, package manager, networking functionalities, and so on. And on top of this part, so the first part here is equivalent, as I said, to what a distribution would provide as a container-based image. And then what OSADL does on top of it is provide the license compliance material, meaning the source code of all packages that are contained in this base image. License text and copyright notices extracted from the source code, and legal notices. So for example, I'll get to that later, but we'll have the base images in two variants. And for one variant, we provide a written offer or just, the warranty disclaimers and so on. So pointing to where people can find the license text and copyright notices. Also build instructions for GPL software and so on. So this comes on top of the distribution content. Now, how do we create this image? So just a few quick steps. You can, of course, use it as it is, but if you're interested in maybe creating it yourself or just following the process of how we create it, it starts with an initial installation with a bootstrap. So kind of installing a minimal base image into a chroot, change root environment. There's tools for that. It's debootstrap on Debian, Ubuntu distributions, APK static on Alpine that help creating such a minimal image, then doing some kind of setup, mainly adding source code repositories, update security repositories to this. And then the next step is already the first compliance step. So downloading the source code using the package manager. And then minimize everything, so everything that's not needed in, as I said, equivalent to the distribution-based images is removed from these images to make them as small as possible. And then we have the interesting step here. Now the license scan happens. So the source packages are kind of exported out of this creation process, are unpacked and patched. And then we run a license scan to create the compliance material, meaning extracting license text, copyright notices, acknowledgements, and so on. So you know this. And of course, it says here, easily run a license scan. And this is, of course, let's say this is the heart of the work that is being done here. And instead of running a license scan, the next better step to get higher quality results would, of course, be using resources from the Ocelot project. I'll give some introduction to the Ocelot project in a moment. We've had, I think, 2 or 3 webinars on the project here for OpenChain before. So if you haven't heard of it, you're welcome to look back at those or get in touch, and we have a lot of resources on that as well. But the general idea of the Ocelot project is to provide curated compliance data for commonly used open source software packages. So at the moment, Ocelot data is used in Debian Trixie base image, so in the most current version. All others still use scans run with scan code, so not curated license information, but simply scan, but they will be adapted as well. So we're in the progress of putting everything on Ocelot material. So let's have a bit of a look into that, because I think this is the most crucial part of the license compliant base image. So how do we reuse the curated Ocelot data to clear base image source packages? And as I said before, I'm assuming some background knowledge here about license data curation, so maybe about using Fossology, for example, and about the Ocelot project. If something that I'm saying is not clear at all to you, then please go ahead and interrupt. So the Ocelot project, you can find more details on the project website. It provides a database of curated compliance information for FOSS components, mainly from the Linux environment. And so you can reuse this data to clear your own software package. You might still use some manual input, some review of the data, especially if, for example, a version is not available exactly in the version of a software package that you are using in your project, but you can still use the baseline data that's available there. But in general, if you do software curation, then this information helps you to reduce the effort and the time required enormously. That is the idea of the project. So, I mean, the basic idea is I've scanned and curated the Linux kernel. Now it took me 2 weeks to get through all files. Why did I have to do that? Someone must have done this before me. Why do I need to do it again and again and again? And of course, the answer is, well, you don't in this case. You can go to Ocelot and have a look at what's available there. Now, how exactly does it work? What are the steps to go from Ocelot curated data and the OSADL Trixie base images using the Fossology license scanner to get to curated compliance material for this particular base image? And these are the steps, and I'll give you some examples of how they are used. As I said, I assume you know basically how Fossology works. So it's a license management tool. You can upload source code, run different scanners on this source code, and then use the user interface or the API to kind of check whether the scanner results are correct. And if yes, confirm them, or if they're not correct, then correct them and confirm them. So not only taking the scanner results as they are, but curating them. This is what Fossology is for. And the steps to get from using Ocelot data with Fossology to get curated information for the Trixie base images are the following. So in the first step, we need to find out which of the source code packages that I'm using in the Trixie base images are actually available in the Ocelot database. And Ocelot offers a REST API to find out which versions and which packages are available. So that's my first step. And the next step is for all the available Ocelot packages, I need to upload the source code of the software that is available or that was curated in Ocelot into my Fossology instance without running any scans. Because, and now this is the Ocelot effect, instead of running scans, I download the curated SPDX reports from the Ocelot repository directly or via REST API, whatever you would like. And then I import this into the Fossology upload. And this is using the import report functionality of Fossology. And this clears the entire Ocelot package automatically. Well, that's nice and pretty, but doesn't really help me for my Trixie base image yet, because now I have the software that is available in Ocelot cleared in my Fossology. What I want is the Trixie source packages to be curated. So now the next step happens. Now I upload the Trixie source packages into my Fossology instance, run all my typical scanners, but in additionally run the reuse functionality of Fossology, referencing the Ocelot upload that I just cleared in the step before. And this step now uses all the information from the curated Ocelot data and adapts them to my Fossology upload to my Trixie source packages, and I only have to curate the remaining files and copyrights, and then I can download the SPDX reports and have curated compliance information of Trixie source packages for the container base image. So this was very theoretical, and I think it helps to maybe take a look at what actually happens in the single practical steps. And there's, of course, different ways of doing that. You can do all of this in via the graphical user interfaces of Ocelot as well as of Fossology. But for an entire base image or even larger software distributions, I think it makes sense to try to automate this as far as possible. And Ocelot, as well as Fossology, offers REST APIs to do so. And so the example that I'm going to show with the next few steps actually uses those REST APIs. So in the first step, as I say, I try to list the available Ocelot data using the REST API that you can find details of how to use this on the Ocelot wiki that is linked here. And basically what I do is to find out which versions that I have in my Trixie base images are available in Ocelot in the exact version, or if not in the exact version, what alternative versions I have. And I basically download the RDF report if they are available, and if not, I list alternative versions. Now, for those packages that I have found, either in the exact version or in alternative versions, I go and I upload the Ocelot source code into Fossology. And the Ocelot source code is given in the README of an Ocelot package. So here, in this example of ACL in version 2.3.2, I find in the Ocelot repository, I found the download location of this package given here. It's also given, by the way, in this info.json file that you can see here. So you can also grab this information in an automated way. And then from this download location, I reference this when uploading the source code into Fossology. So here is the REST API call for Fossology. I upload from a URL, from the ACL URL that I just took from the Ocelot repository, and I upload this into Fossology without running any scanners. So simply uploading the Ocelot package. And now, as I say, now the Ocelot magic happens. I download the SPDX report from the Ocelot repository and upload this into the Fossology instant as well. So here I use the import report functionality, and I upload this into the Ocelot source package that I just uploaded in the previous step. And now, just to show you the Ocelot magic, I can query how many files of this package are already cleared and how many files actually have any license information. And in this case, it shows me with this single import step that all files are cleared. So total files of interest, so total files where information could have been found, have been cleared by the Ocelot import. And now we transfer this to our Trixie source package. So I upload the identical Trixie source package that I now have as a file from the base image creation step. I upload this into Fossology. And in the next step, I run some scans. So I run all my copyright, my scans, my Monk, Nomos, and Ojo license scanners. And here in the last bit, I run the reuse scan. So I reuse the information from the Ocelot package and adapt this, transfer this to this upload here. And now I get the clearing status of Trixie source package. So this is an alternative way to get a clearing status, just to mix it up a bit. And here you see that I have 5 files that still need to be cleared. So of the 170 something files that this source package contains with license information, by reusing the OSADL package, most of them were already cleared, and the only thing I have to look at manually are now 5 source code files. So as you can see, that saves me quite a lot of work. And of course, this next step, actually clearing those 5 files, this is something I can't do automatically. I have to do manually, and I'll do this via the Fossology user interface. I'll not get into the details here. So you basically go and clear these 5 files. And once you've done this, you can download the SPDX report or generate it and then download it. And you do these 5 steps. Basically, you do them for all source code packages that are available in the Trixie image and also in the OSADL database. And then you have a collection of curated license and copyright reports for the base image. So that was this simple step that's here just called license scan. And of course, there's different ways of doing it. The best quality is definitely if you have curated license information, and you'll save a lot of work by using the OSADL data here. The next step in creating the base image is some information. So basically creating and displaying the legal information that we have now collected in the license scan. So making sure, for example, that when the base image is started, that it prints some welcoming message and tells you about the licensing information. So this is how we do it in the base image. Of course, if you depending on how you use the container image, you might do it in a different way, but you can still use the texts that are given here. And once all of this is done, so the license scan or the source code is contained in the base image, the information is displayed correctly, then we can create a container image from our change root environment and import this into our container instance. Now, as I mentioned before, this container base image that we've now created in these given steps are available in 2 variants from OSADL. Because, as you know from the GPL, which we're still taking as the license with the strictest obligations that we usually find in such a Linux-based distribution, we have 2 options of how to fulfill our disclosure obligations. The first option is to immediately deliver all source code along with the binary distribution, and the other option is to deliver a written offer and then only deliver the source code on request. And these 2 options are also mirrored in the variants that are given in the OSADL base image. We have one base image with immediate source code delivery, so all the source code and then a node with legal information and build information and so on are already included in the container image. And because everything that's needed for compliance is included in the image, this image is also available on Docker Hub. So you can find it here and reference it. It's a compliant base image, so you can reference it, for example, in your Docker file, and then you don't have to worry about license obligations for this base image. But there's also the variant for delayed source code delivery. So this image doesn't contain the source code. It contains the extracted compliance material. So the material that we've just created, for example, with the OSADL database. And then it also contains a written offer for delayed source code delivery. And then this container image is archived together with the entire source code, including rebuild instructions for later delivery. So they're provided separately from the actual container image. And for both of those, instructions on how to use the base image and how it is created are given as well on the project page. Now, of course, as you can think, here again in a bit of a better display view, as you can probably think, the base image with all source code included is a lot larger than the typical base image. And that is also a reason why in some cases it's not used, because typically this so the base image for immediate source code delivery would be, from a license compliance point of view, would be the easier bit to use. But you might have size restraints and be forced to use the base image with delayed source code delivery. And this is smaller because it doesn't contain source code. It only contains the extracted compliance material created with the OSADL project and the written offer. And then the source code is provided separately. Just to give you an idea that this is actually a really relevant size difference, I'll pick up the sizes of the current Trixie container image that I just created yesterday. So with all the source codes, or all source packages included, this has 420 megabyte, while the delayed source code delivery image has only a bit over 100 megabyte. Just to give you a comparison, the Debian Trixie Slim image, which is the equivalent to this Trixie OSADL base image, has about 80 megabyte of size, so the running container of those. And here the difference between the delayed source code delivery and the Debian Trixie delivery, that is basically the compliance material. So as you can see, it is a significant size difference. But we'll get back to that in a bit. So as I said, they are available, these base images, in different variants. The project page is osadl.org/base image. You can download both variants of the OSADL base image there if you work in an OSADL member company. If not, we'll make them available on request. So just get in touch with us. And the source code delivery image is also available on Docker Hub for everyone and to be referenced in a Docker file directly. They're available in different Linux distributions. So we have Alpine Linux available, Debian, Ubuntu in various architectures, and all supported LTS versions. They are updated regularly. We'll try to be in about a week from the updates delivered by the distributions. Sometimes we're a bit slow due to holidays or so on, but usually it's around a week from when the distributions provide updates. If you're missing some variant, if you're missing some base distribution or some architectures, then please get in touch. So we're happy to create them on request, but those are the ones that are requested so far. Now, how can you use this? Just quickly, so we have the base image now, and you can, of course, build an application on top of that. For example, you can reference it in a container file, or that you build yourself, or if you use a container, usually from a container repository, it also comes with a container file, and you can see in the top line usually what base image this particular, for example, a database container image or so on, is built on. And this from line that you find in a container file, you can replace this with the equivalent base image from the OSADL base images. Now, any software components beyond the base images, so any additional layers that you put on that, are of course individual, and therefore you must fulfill the license obligations for these but yourself individually. But you can use the instructions, so what I've just given now, or what you can find on the OSADL project page on how to build a base image, you can use these instructions to also fulfill license obligations for additional layers. So the recommendation is basically to do each layer separately, because once they're all in the running container instance, then you can't access the lower layers easily with the package management system. So just do each layer separately. Now, I mentioned before that there is work ongoing in the OSADL project, and there is some overlap here with the container images because we have this issue of having basically too much source code. Because you know that from one source package, usually many binary packages, or at least several binary packages, can be built, and not all of them are actually used in the OSADL base image. So we're not distributing everything that we do license compliance for at the moment. We're doing too much. And this, of course, makes the base image larger than it needs to be from a compliance standpoint. And part of the OSADL project, we do source code provenance analysis of binary software, meaning analyzing, evaluating which source code files are actually used to create a particular binary that is then finally distributed. And of course, when I know that which source code files actually create a binary, then I can concentrate my compliance work on this source code. So I can deliver this source code along with the software, or I can extract compliance information only from these source code files and not from the entire huge source package, which makes the distribution just so much larger. So this information, the source code provenance information, can be used to reduce the source code that needs to be analyzed and delivered. Well, as I said, it's ongoing work, but you can already have a look at what this looks like, how it works. If you go to the OSADL website and go to tools, and then you find the section on call graphs and dependency lists, including source code provenance. And here you can search for either a package name or a binary name directly. Search for it and then choose the version that you would like to see. And from there, you can get a reduced SPDX file that only contains the source code information that is actually used in this particular binary build. And to get this information, to provide this information, we use a tool called CallGraph, which also originated from Armin Hemel, and which OSADL has extended. You can find information on that on osadl.org CallGraph. Of course, also an open source tool, like everything I talk about here. CallGraph displays, in the first instant, displays link dependency of ELF packages, and also now does this source code provenance. Also, the link dependencies, of course, can be relevant for the OSADL base images or for containers in general when you check for license compatibility, especially with strong copyleft licenses. And we're actually evaluating the call graph of the entire base image to make sure that this fits, but as it's all open source software, we don't expect many difficulties there. More interesting, I think, is to use the call graph tool when you add proprietary application to the base image or even to other systems, because then you can evaluate the link dependencies. So what libraries are used for your proprietary application, and check whether there are any licensing issues there. But just to give you an idea of what this looks like when we look at the base image, the call graph for the entire Trixie base image looks like this. So it is something that we'll need to look at in detail, but still for an entire system, you can see that it is manageable, I think. Of course, this information is also available in text form, so we don't need to evaluate every single line that we find here. But you can already see, for example, on the top left corner here that there are a few libraries. So the blue dots are libraries, the orange dots are programs. And you can see here that there are a few libraries that are actually not used at all. So the next step would be to check the base image whether we can remove those libraries. If they're not used, then we can remove them, so the image becomes smaller as well. Now, to summarize all of that, we have the problem, and we still have the problem, even though we started with all of this 5 years ago, and we hope that it would change by now, but it really hasn't changed. License obligations are usually not considered when distributing containers, even by those providing them via container repositories. Another issue is that distributing container files doesn't really help you to get around this problem, because distributing container files is, at least with respect to copyright law, equivalent to distributing software, as whoever writes the container file is the one who controls the software distribution. And therefore, license obligations must be fulfilled no matter if distributed directly or via a container file. To help you do that, OSADL creates the license-compliant container base images, updates them regularly, provides them in different variants and versions, and also as a choice for different cases of how to fulfill disclosure obligations. And you can use these base images either to learn of how you can fulfill license obligations for containers, or to use them directly by building customized applications on top of these images. And as I promised before, I'll give you the references of what I mentioned before. So the white paper that started all of this off by Armin Hiemel is available via the Linux Foundation at this URL here. And the legal opinion that Till Jäger wrote for OSADL is also available publicly at the DOI given down here. And this is also where the reference that I mentioned before on controlling distribution and what European and German courts say about this comes from. So if you want to read up on that, have a look into that file there. All right, now I talked quite a lot and didn't really give anyone any chance to ask any questions. So are there any questions open? Anything that I haven't touched or that was unclear?
And everyone should feel free to jump in here, no matter what your level in dealing with containers and so on is. We're very open to any type of question. And I'd like to get started with one. Have you found much international engagement with your work yet? Because this is fairly sophisticated work, legal opinion, analysis, actual implementation methodology. I'm just wondering if people around the world have started to talk to you.
Well, I think you probably know this problem with things that you provide as open source. We don't really know. So we don't know who is using it. I can't say that we've gotten a lot of international feedback. We do get some feedback from OSADL member companies who we're in touch with directly. So we know of quite a lot of OSADL member companies who only use OSADL base images for their container applications. And we, of course, see the download numbers on Docker Hub, which are, I think, fairly respectable. I mean, but with feedback, I can't say that there's a lot.
That's a common problem. People often ask us, how many people are using your standards? And the question can only be answered by, well, the ones that told us are on our website, but goodness knows.
Yeah. So, but as I say, we started out with a lot less variants, so with a lot less architectures and with a lot. So we didn't have any Ubuntu-based images in the beginning, for example. And those additional architectures, those additional variants were added on requests, so from people who use them. And I know that when I'm 2 days late with a minor version update or something of a distribution, then I usually get emails immediately. So I do know that some people are using it regularly and are really waiting for updates as well.
We were very fortunate in OpenChain to get help from some companies like PwC that plugged us into their own surveys, which gave us data we wouldn't have otherwise. And, you know, I'm continuing to talk with OpenChain partners about including us in further surveys around the world. So maybe we can cooperate to try and include your work in future surveys as well, just to try to dig out some of that data around usage and so on.
Yeah, that would be interesting to know.
Well, everyone, do you have any question for Karen?
Well, I'm wondering, is anyone here who is using the base images already? So maybe you just wanted to get an update or so on, who has heard of them before. We'll do our own survey right now.
We have 24 on the line and 24 officially shy.
Or really
Dirk
not
is,
using them yet. So that might be the answer as well.
It
All right,
might.
there is a question.
Dirk said something in the chat.
No license compliance question really, but maybe an interesting insight on regulation compliance for the container image distribution situation.
Do you want an insight from Karen on it, or do you have an insight to share?
Sorry, needed to get my setup right here. Oh, yeah, hi, Karen. Thank you very much for the enjoyable talk. Yeah, the question is that, so when we talk about compliance, it has these two main sides, usually now, license compliance and compliance with regulation. And I very much enjoyed the discussion of license compliance and all the hard work. So I wanted to ask about the other side, regulation, compliance with regulation, whether you had any interesting insights to share there. If you worked with Till Jäger, maybe he had saw anything that follows from a not very new, but still fairly recent new form of distributing software by container images.
So it is a discussion that is kind of outstanding. So we have it. We will have to take care of that, of course. One of the points is, I think, and I mentioned this, will be regular updates. So that we'll be able to provide to guarantee the provision of regular updates as well, which will be important for most other regulations. But I can't really say more on that yet. But we'll definitely have it in our focus. And as soon as there is more information, if there's anything special coming up, then we'll make this available as well.
Can I ask a follow-up question then?
Of course, please.
So since you're making this image available, you're a distributor, but then some vendor picks it up and they distribute, and of course they are responsible. Now, by way of what's most on my palette these days, Cyber Resilience Act in Europe, probably for you similar. Vendors need to look into the supply chain and work with suppliers to raise the level of security and all of that. So does that mean you're ready for vendors to approach you, or is that what you can't quite talk about right now? How you as a supplier in a supply chain then would work with those who use your work or distribute on your work?
Yeah, that's what I meant mainly with things that we'll have to look into in detail. I think the way that we're set up is a good basis. So I don't think we'll run into major problems, but it is definitely something that we'll look into. But the good thing is we have all the information available that we'll need to then comply with CIA regulations, I believe.
All right, thank you very much. I think it will be interesting to see what it means that vendors are responsible for making sure the supply chain follows best practices and all of that. So I'm guessing you will look into how to portray that or just do it, obviously, so that your users are satisfied. For all that I see, there's just a lot of insecurity on what that actually means.
Yeah, I think it'll end up with additional documentation, probably more than changing anything about the base image itself or about how we supply it. I think it'll end up with just delivering extra documentation. For example, the SPDX as we deliver it now and as it is compliant with the SPDX specification as well, is actually not entirely compliant. Well, we'll have to kind of compare it as well to what the BSI, for example, requests for the SBOM, which I think differs in some cases from, at least from current SPDX specifications. So this is something we'll have to look into, I think. Thank you for your question. And there was another comment from Martin. We use tarballs in a similar way to the OSADL approach internally, but we don't typically distribute. But if we did, we'd be compliant in the same way. If we did more distribution and use containers, I'd look again at OSADL. Well, thank you. I think using internally is, of course, with open source software, never a compliance problem. Also, using internally means that you can archive all the source code. So if you later on change to external distribution, then you already have all the information available, and you can look at the source code as well. So with the source code delivery in the distribution, it's usually size is the problem there. So if you're just internally, you don't have that issue. Well, in any case, if you come up with questions later on, you're welcome to get in touch. I'll jump back to the first slide and my email address there. So get in touch with us. You'll, of course, also find contact information on the OSADL project page, on the OSADL Base Image project page, also on the OSADL project page. So any questions on either of those or on practical applications in between, you're welcome to get in touch.
Fantastic. Thank you very much indeed. And just one last thing for everyone, a community request. We're doing a small survey from people who have used our standards or even have just read them. And we would deeply appreciate if you took 2 minutes to fill out the survey. We're about to enter another edit cycle, and this feedback will help guide our work. Our first meeting to discuss it happens tonight. It's the North America-Europe meeting for Specification and Education Work Team. And if we have a few comments in by then, it will be very useful for us. So please take 2 minutes, have a look at that link and see if there's some feedback you can provide. And with that, Karen, thank you for a wonderful survey. A wonderful presentation. I aim to publish it as a recording on our news blog and in our webinar section by Friday. And let's follow up soon with another webinar about the broader work of OSADL to share with the community.
Yeah, we'll definitely have some news on the OSADL project as well. So I gave a glimpse into the ongoing work there, and I'm sure we'll be here in another OpenChain webinar with more on that.
Fantastic.
Thank you, Shane.
Thank you, Karen. Thank you all. Have a beautiful day.
Bye-bye.
Bye-bye.